All right, here we go. Second lesson. A second lesson on solving absolute value equations. We're going to do more complicated equations today. So again, textbooks open to page 30, and we're looking at absolute value of x. First, something simple, something we talked about yesterday, we've already established this. Absolute value of x is 5. So we're going to say, okay, what can x be? Well, we already know. X could be 5 or x could be negative 5. I want you to notice, first off, right side of this thing. Okay, so the right side of the equality is 5, right positive. Okay, so the right side is positive. When the right side is positive, how many solutions make this true? Well, there are 2. Okay, so I want you to put this on the side of your notes. The absolute value of x is equal to a positive value. We have 2 solutions. Okay, now we're going to look at the absolute value of x is equal to 0. Stop and think for a moment. What would make this true? Okay, so if you look, you see, x could be 0, okay? X equals 0. Do we write or x equals negative 0? Opposite of 0? What is 0? Okay, 0 is nothing. All right, so nothing. Okay, can we have negative nothing? Well, first off, can we even have nothing? Okay, so I like this better. X equals nothing. We write 0 to represent nothing. Okay, so man can't comprehend what nothing is. So, and if you go and stop and think about it from, go home, think, nothing, blackness. You can't, okay, you can't think about nothing, or you cannot understand what nothing is. 2 things we can't understand, forever, and we can't understand nothing. Okay, so forever, going on forever, and ever, eternity. No, you cannot understand this. Forever getting larger. You can also not understand nothing. Okay, so is it blackness? Blackness. No, blackness is something. White slate, clean, clear. No, there's still something there. Okay, so we cannot comprehend nothing. If you can go home and figure out what nothing is, let me know. Okay, so if you can figure out what nothing is, if you can go home and figure out what nothing isn't, yeah, that's better. Let me know. Okay, so here, that's better. X equals what? X equals... That's better. Okay, so x equals nothing. Okay, so now that we've spent a long time talking about nothing, okay, so we say absolute value of x is nothing, then x must be nothing. I like that better. But we're going to write 0. Okay, so man puts a symbol to represent what nothing is. Okay, so we're going to put 0. 0 represents absolutely nothing. Okay, so the absolute value of x equals 0. How many solutions do we have? We just have 1. Okay, so we write what? 1 solution. And the absolute value of x, what do you think this one's going to be? So we have positive 0. We're going to look at absolute value of x equals negative. Okay, what is this? All right, let's write absolute value of x equals negative 5. What would make this true? Well, hopefully you only guess maybe 2 values, so the absolute value of 5, what's the absolute value of 5? Absolute value of 5 is 5. Okay, so that's not it. Absolute value of negative 5 is also 5. Well, that's not it. Okay, so notice, when we say the absolute value of something here, absolute value of 7 is 7. Absolute value of negative 7 is 7. What type of value does absolute value equal? It equals a positive value. So circle this. Circle this. That's what? Positive. That's positive. So the absolute value is an entity. Okay, this entity, absolute value, is always equal to what type of value? A positive number. A positive number. So does this make sense? Circle this here. What type of value is that entity? That's what? That's a positive value. Does it make sense? Does it make sense to say that a positive value is equal to a negative value? No. It makes no sense. So what makes this true? There's nothing that makes this true. So how do we say nothing makes the equation true? We say that the equation has no solution. Nothing makes this true. Okay, so we say no solution. This is the symbol for no solution. There is nothing that makes this equation true. It's a circle with a slash through it. Or you can also use empty braces. Okay, this means nothing in there. There are many types of equations that don't have a solution. Okay, let me give you another example. If I write on the board x equals x plus 1, something is equal to itself plus 1. Pick numbers and put them in here. Pick a number, pick a number, pick a number. 3. Okay, so try 3. 3 equals 3 plus 1. Nope. Okay, try 4. 4 equals 4 plus 1. No, that's not true. Okay, so you start to see 189.2. Does 189.2 equal 189.2 plus 1? No. Okay, so you start to see that nothing makes this true. This equation also has No solution, because it is not possible to have something equal to itself plus 1. So not every equation even has a solution. So we see equations can have what? One solution. Equations can have, like we did first day, one solution. Well, here's one solution. Equations can have what? Two solutions. Equations can have no solution. Okay, so we're going to say if the absolute value of x is equal to a negative number, how many solutions do we have? There is no solution. Okay, so this is the first thing we have to establish. Okay, so absolute value of x. Okay. All right, now let's go into look at some problems. Before we get into these problems are a little more complicated than what we did yesterday. Let's write this. Number one, most important thing here. Number one, most important thing, and the first thing you have to do when dealing with an absolute value equation is isolate. Isolate the absolute value. What am I talking about? Well, let's give an example. Okay, so here, let's start with this absolute value equation. Now, yesterday you saw two methods, geometric method and what? Algebraic method. Okay, so 3 times the absolute value of x minus 4, let's make that 5, plus 4 equals 13. Okay, so this is just slightly more complicated than what we did yesterday, but not that hard. What do I say? Isolate. Isolate. The first thing we have to do is isolate the absolute value. So what are we talking about? All right, underline this. This is your absolute value, okay? And you understand that, here, maybe put a box around it. Okay, you understand that this is what? Positive. We just said that entity, that absolute value entity is a positive number. Okay, so this, what's in the box, is a positive number. This has to be by itself on the left side of the equality. Here's the division of the equation. The equality divides the equation in two halves. So this needs to be by itself on the left side. So we have to get rid of two things. We have to get rid of what? 4 and 3. So just like we did day 1 with linear equation, we have to get rid of two things. We have to get rid of the 4 and the 3. We start with the addition. 4 moves to the other side, becomes minus 4. Cross it out. So we have now 3 times the absolute value of x minus 5 is equal to 13 minus 4 is 9. Now, okay, we've gotten rid of the 4, now we have to get rid of the 3. 4 was being added, we subtracted, 3 is being multiplied, so we divide. So divide, put the line underneath the whole, okay, this is a unit. Divide the whole thing by what? 3. Divide the whole thing by 3. Okay, so the 3's cancel, and we're left with the absolute value of x minus 5. The absolute value of x minus 5 is equal to 9 divided by 3 is 3. Okay, so here you go. It's isolated. What do I mean isolated? The absolute value is by itself on the left side of the equation. Okay, so we say that the absolute value is isolated. So when I say isolate the absolute value, the first thing you have to do, this is what I mean. That means get rid of the 4, get rid of the 3. Now we stop here. Stop sign. Okay? Big stop. You stop here and you check. Okay, so is it isolated? Yes, absolute value is isolated. We stop and check. Check what? Check the right side. Look over here. Okay, so we said if the right side is positive, notice that this absolute value is isolated, isolated, isolated. If the right side is positive, how many solutions do we have? We have 2. If the right side is 0, we have 1 solution. If the right side is negative, we have no solution. Okay, so looking here, the absolute value is isolated. We look at the right side. Is the right side positive, 0, or negative? It's positive. So how many solutions do we have? We have what? 2 solutions. Okay, there are 2 things that make this equation true. Now, once you get to this point, we now solve it 2 ways. Okay, so limited board space. We're going to have geometric method. I'm just going to abbreviate GM for geometric method. Okay, geometric method says we have to find the center. Okay, so looking over here at our equation, to find our center, we look at what's inside, the negative 5. So remember, this is our center. Okay, negative 5 is our center, and we're going to have what? Opposite of negative 5 is 5, and our distance either way is the number out here, so distance either way is 3. Okay, so to go to the right is to add, 5 plus 3 is 8, and to go to the left is to subtract, 5 minus 3 is 2, so we get 2 solutions. Our variable is x, so we have x equals 2 or x equals 8. Now, second method is what? Algebraic method. Okay, algebraic method says we're going to look at what's on the inside. Okay, so what's on the inside? There it is, x minus 5. Okay, so what's inside has to either equal 3 or what's inside has to equal negative 3. So we're going to write what's inside is x minus 5. X minus 5 is equal to 3. Or, connected word is or, x minus 5 equals negative 3. Now, draw a line down the center, add your 5. Cross it out, x equals 8, or Draw a line down the center, add 5, cross it out, x equals negative 3 plus 5 is 2. Notice that these solutions match these, so both methods get the same answer. Okay. Now, lastly, by the way, number line, okay, our solutions are where? At 2 and at 8. Okay? So mark the locations. This is the x-axis. All right, so you've seen the first thing we have to do when dealing with more complicated types of absolute value equations is what? Isolate. After we isolate, we then stop and check. Is the right side positive, 0, or negative? If it's positive, we have what? 2 solutions. If it's 0, we have 1 solution. Or if it isn't 0, and if it's negative, we have what? No solution. All right, now, in your book, I want you to attempt problem numbers 9 and 11. Okay, pause the video and attempt numbers 9 and 11. Okay, let's see what happens here. Numbers 9, numbers 11. Okay, number 9 says the absolute value of b minus 3 plus 8 is equal to 3. I wrote that down right. Okay, so the first step, number one thing, I just erased it. Number one thing was what? Isolate absolute value. Okay, so we have to, number one thing, isolate absolute value. So that means get rid of, okay, so we draw a line down the center. Look, this is your absolute value unit. So we have to get b minus 3 absolute value. This thing, the absolute value b minus 3 by itself. So we have to get rid of what? Get rid of the 8. So move the 8 to the other side. It's being added, subtract 8. We end up with what? The absolute value b minus 3 is equal to what? 3 minus 8 is negative 5. There it is. Okay, so what do we do here? We stop and we check. Students, don't go forward. Students, keep going. They keep working. The more work you do, the less points you get. Okay, so the less work you do, the better. Okay, so smart is less work. Okay, so don't go forward. Rather stop and think. Look, absolute value. This is a unit. Okay, this is a positive unit. Can a positive unit equal a negative number? No. Okay, so the right side is what? Notice, right side is, if the right side is negative when it is isolated, we have what? No solution. So you write 0 slash through it or empty braces. Okay, so for number 9, the answer was no solution. Okay, let's look at number 11. Okay. Number 11 says negative 2 times the absolute value of 5y minus 1 is equal to negative 10. So now that you saw the last one was no solution, alarms, bells, whistles, flashing lights should be going off. Okay, what do you notice about your right side? Your right side is what? Right side is negative. Uh-oh, you should immediately notice that this is a problem. Okay, so we should be worried about what? No solution cases. But if you notice here, we have not isolated yet. So what do we have to get rid of first before this unit is isolated? We have to get rid of what? Negative 2. Notice negative 2 is not being subtracted. It's being what? Multiplied. So what are we going to do? We're going to divide by negative 2. And we're going to divide by negative 2. So this actually does have solutions. We have the absolute value 5y minus 1 is equal to negative 10 divided by negative 2 is what? Positive 5. So notice, the right side was negative to begin with, but once you divide by the negative, what happens? The right side becomes positive. So when do we stop and check? We stop and check when the absolute value is isolated. Notice, 5 is what? So we stop here. 5 is what? Positive. Okay, so we look over here. If the right side is positive, we have 2 solutions. If it's 0, we have 1 solution. If it's negative, we have no solution. So we have the absolute value 5y minus 1 equals positive 5. This has solutions. How many? 2. Okay, so now we go to our 2 methods. We have geometric method. Now, I would expect if you finished, if you got here and you did try to solve it, you found that there was some problems here with the geometric method, okay? That your solutions in the geometric method did not match your solutions in the algebraic method. So let's look. I encourage you to solve using the algebraic method first. Okay, so the algebraic method says that what's on the inside has to either equal 5 or negative 5. So we're going to write 5y minus 1, what's on the inside, is equal to 5, or what's on the inside equals 5y minus 1 equals negative 5. Okay, now we solve. Okay, so put the negative 1 on the other side, becomes plus 1, so now we have 5y, cross it out here. 5y equals 6, divide by 5. Divide by 5, what do we have here? Y equals 6 over 5. Now, this means nothing to me. Okay, so we need to make this make sense. So how do we change a mixed number, an improper fraction to a mixed number? We're going to divide. So take notice 6 and divide by 5. You say, what? Okay, hold on. You understand that 4 divided by 2 is what? 4 divided by 2 is 2. Can we rewrite this as 4 divided by 2? Yes. Okay, so we get 4 divided by 2 is 2. That's our answer. So you take the top and divide by the bottom. Okay, so 6 divided by 5. 5 goes into 6 how many times? Once. 1 times 5 is 5. Subtract 6 minus 5 is 1. Okay, and now we're going to write, this is our remainder, so we're going to put a little tiny R1, remainder 1. So how do we write your answer here? Y equals, circle this is your main number, y equals 1, and you take your little remainder 1 and put it over what you divided by 5. Okay, so 1 and 1/5. Okay, so our answer is y equals 1 and 1/5. This we can find on the number line. 6/5, no, but 1 and 1/5, yes, we know what that is. It's between 1 and 2. Now, or, same thing, plus 1, we end up with 5y equals, negative 5 plus 1 is negative 4, divided by 5, y equals negative 4 over 5. Now, in this case, you do not need to divide like we did over there with the 6 and the 5. You do not need to divide because the top is smaller. This value is between between negative 1 and 0. Okay, so do not divide if the top is smaller. Now, the geometric method, okay, we're going to do the same thing that we did earlier for the geometric method, except we're going to make some small changes. Now, I told you guys that we start with a center. So what should our assumed center be here? Okay, so we start with what should be our center, 5y minus 1. So according to what we learned yesterday, the center should be positive 1. So put positive 1, and our distance should be 5. Okay, but this positive 1 is not actually the center. This is wrong, and our distance that should be 5 is not actually correct. Okay, so the center is not 1, and the distance is not 5. Okay, so what do? What's different about this? What's different about this and what we did yesterday? Here, do it anyway. Let's just go with this. Okay, so 1 plus 5, to go to the right is add. 1 plus 5 is 6. To go to the left is subtract. 1 minus 5 is 4. I'm sorry. 1 minus 5 is negative 4. Okay, let's see. Do these match? Look, no, it's 6. Do you see that that matches the top? 6. And negative 4, do you see that this matches the top? Negative 4. What's different? Okay, this is what's different. Notice that 5 is being multiplied. It's not in our other problems. Notice that what's in front of y? 5. 5 is being multiplied by y. So what this means, to use the geometric method, we're going to divide everything by what's being multiplied by y. So we're going to divide everything by 5. Divide everything by 5. The distances get divided by 5. The center gets divided by 5. And the answers get divided by 5. So what is our actual center? Our actual center is 1/5. And our distances are not 5, but rather what's 5 divided by 5? 5 divided by 5 is 1. 5 divided by 5 is 1. To go to the right, 1/5 plus 1 is 1 and 1/5. To go to the left is 1/5 subtract 1, which is negative 4/5. Okay, so I tell students to do this, then divide everything by 5. That's one way. But you start to see that the geometric method is not going to be the most efficient method. The most efficient method would be the algebraic method. But again, you do get the same answers. We put these on a number line. This is the y-axis. We have negative 4/5. We have 1 and 1/5. And what are these between? Well, negative 4/5 is between negative 1 and 0. I'm all off here as far as correct distances go, but all right. Negative 1 and 0. And 1 and 1/5 is between 1 and 2. So I want you to tell me what these are between. Now, 1 and 1/5 is very close to 1, and negative 4/5 is very close to negative 1. So this is not to proportion, but or not to scale, but at least it gets the point across. Now, all right, next, I want you to attempt problem numbers 27 and 29 on page 30. Problem numbers 27 and 29. Okay, and we're almost done. Problem numbers 27 and 29 on page 30 of your textbook. Okay? Problem 27, again, pause the video and really attempt these, guys. If you work it on your own, okay, and then you see what you did wrong, you're learning more than just simply watching. There's a difference between watching me do math and you actually doing it yourself are two different things. So you want to make sure that you're practicing these and then seeing what you did wrong. So number 27, assuming that you've already attempted this, we have 5 times the absolute value 5 times the absolute value of q plus 6 equals 20. And again, what's the first thing we need to do with these equations? The first thing we need to do is what? Isolate the absolute value. Okay, so notice the absolute value unit is the absolute value of q plus 6. So what do we have to get rid of? 5. Now notice 5 is being multiplied. We do the opposite. That's divide by 5, divide by 5. We get the absolute value of q plus 6 is equal to 4. Now, is it isolated? We stop. Is it isolated? Yes, it's isolated. Now what do? We check the right side. Okay, so the right side is what? Positive. So if the right side is positive, what do we have? 2 solutions. So how many values make this true? There are 2 values. Okay, so we're going to now solve using the geometric method and the algebraic method. I expect you guys to start to, eventually we're just going to not use the geometric method. But for now, keep practicing both. Okay, so let's always start with the algebraic. We start with what's inside. Q plus 6, okay? Now, what's inside has to either equal 4 or negative 4, so we're going to write Q plus 6 equals 4, or Q plus 6 equals negative 4. Now what do? We move the 6 to the other side, subtract 6, Q equals negative 2, or move the 6 to the other side, subtract 6, cross it out, Q equals, the signs are the same, you add, negative 10, and we have 2 answers. Okay, so there are 2 solutions to this equation. Can you always plug them back in and check? Yes. If you're unsure, plug them back into the original. Erasing this up here. Let's plug in negative 10. Okay, so negative 10 in for Q. Negative 10 plus 6 is negative 4. The absolute value of negative 4 is 4, and 4 times 5 is 20. So that checks out. Put in negative 2. Negative 2 plus 6 is positive 4. Absolute value of positive 4 is 4 times 5 is 20. So they do check out. Geometric method says we need a center. Okay, so our center is what? Center is the opposite of positive 6, so we get negative 6. And our distance is either way or what? 4. So we're going to go 4 units to the right, 4 units to the left. Now, question, is anything being multiplied by Q? The answer is no. Okay, so we don't have to divide these distances or the center. Negative 6 plus 4 is negative 2. Negative 6 subtract 4 is negative 10. Okay, so we get Q as our variable. Q equals negative 10. Or Q equals negative 2. And again, lastly, answers on the number line. Solutions are negative 10, negative 2, and this is the Q axis. Okay, so, all right. Lastly, number 29. Number 29 says 3 times the absolute value of 2a minus 4 is equal to 0. Okay, nothing. All right, okay, back to the nothing thing. All right, so we start with isolating. Okay, we start, notice 3 is being multiplied, so what are we going to do? Divide by 3, divide by 3. Uh-oh. Okay, so we end up with 0 over 3. Let's talk for a moment. 0 over 3. What is nothing divided by 3? Nothing divided by 3. This is okay, this is acceptable, this is nothing. Okay, now, 3 divided by 0, what is 3 divided by nothing? Okay, well we call this, this makes no sense. We say that this is undefined. Technically, I believe indeterminate is proper, but most books say undefined, but this is no value, so this makes no sense. But 0 over 3 is okay. We're going to say that this is 0. Okay, nothing divided into 3 parts is still nothing. Okay, now, so we isolate. We get the absolute value of 2a minus 4 is equal to nothing. Okay, now, stop here. We stop. Is the absolute value isolated? Yes, it's isolated. Okay, so we look. Is the right side positive, 0, or negative? Well, the right side is what? The right side is 0. So how many solutions are we going to have? We're going to have 1. And I think this makes sense. When we put this in terms of the geometric method, you really see it here. G down for geometric. And then we have what? Algebraic method. Okay, let's start, though. Let's start with the algebraic method. We write what? Our equations. Okay, so what's on the inside is 2a minus 4. So 2a minus 4 equals what? Oh, that's better. That's better. Nothing. Okay, so, okay, our symbol, hopefully today you're starting to think, okay, Nothing. Okay, we put something there to represent nothing. So 2a minus 4 is what? Nothing. Okay, so we're going to write 0. Or do we write this? 2a minus 4 equals negative nothing? No. Okay, so this makes no sense. So how many equations do we end up with? Just what? Just one equation. Okay, so now solve, add 4. We get 2a equals what? 2a equals 4 divided by 2. Okay, a equals what? A equals 2. One solution. What solution makes this true? The number 2. We can plug it back in. 2 times 2 is 4. 4 minus 4 is 0. The absolute value of 0 is 0. Okay, now, geometric method says find a center. Our assumed center should be what? Negative 4. Opposite of negative 4 is 4. And what is our assumed distance? Our assumed distance is what? 0. But is this necessarily correct? No. Notice that something is being multiplied by a, namely the number 2. So we're going to divide everything by 2. Okay, so we divide our distances by 2, we divide 4 by 2. So is our center actually 4? No. The center is 4 divided by 2, which is what? 4 divided by 2. Our actual center is 2. And what are our distances? 0 divided by 2, we talked about, is 0. Okay, 0 divided by 2 is 0. So to go 0 units to the right, 0 units to the left, what is our answer? Okay, we didn't go to the right, we didn't go to the left. So the answer is the center. Okay, so the answer is the center. So you see now that if the distance is 0, the actual solution is the center itself. So the center is what? 2. X equals 2. We put this on, no, I'm sorry, A. A equals 2. We put this on the A axis. The answer is 2. One solution. Okay. Now, before we end this video, I want to talk to you very briefly about mistakes not to make. Do not make these mistakes. Okay, so if I write, for instance, 3 times the absolute value of x minus 5 is equal to 7. Do not make this mistake. Okay, absolute value is not the same as parentheses. Students try to do this all the time. You know, they try to take the 3 and distribute. I want you to think of the absolute value as jail bars. Okay, what's inside is locked up. You cannot use distributive. Distributive property does not apply here. You cannot take 3 and multiply by x and 3 and multiply by 5. Well, okay, technically there are some rules here, but I'm not going to get into that right now. But I want you to say this is not allowed. For now, this is not allowed. Okay, so you're not allowed to distribute inside an absolute value. So this is wrong. Okay, capital, wrong. Don't make this mistake. Students do this. The absolute value of 3x minus 15 is equal to 7. Okay, so this is completely wrong. Lots of points gone, guys. Don't do this. Okay, so don't do this. Secondly, students make this mistake. Absolute value of x minus 5 is equal to 7. Students try to do this. Okay, so plus 5 cancel and get the absolute value of x equals 12. No! Okay, so this is also wrong. What did I say? Wrong. Think of these as jail bars, guys. What's inside is locked up. What's inside, there's nothing you can do to what's inside. You can't take anything out. You can't put anything in. Okay, so this is also wrong. Do not make this mistake of adding 5 and taking it out of there. Okay, so no. All wrong, all wrong. Okay, all right, so that should conclude at least, I think that clears up a couple of the mistakes that can be made. There are more, but I think that's the 2 main, most common mistakes. But anyway, all right, so absolute value equations. All right, next we will be covering absolute value inequalities. We'll talk about that in the next lesson.